Okay, so this is going to be my part 2, where we actually use the axis of symmetry and, compute it, right? Because we had it laid out last time, but in the other graph, we just found the axis of symmetry from the graph and didn't actually use the formula. So this time we're going to find the axis of symmetry given the function, right? And then we'll figure out some graphing stuff. But first, I just wanted to let you know that when we're in standard form, this is our A, right? The coefficient in front of x squared is the A term. The coefficient in front of the x term is B. And the coefficient, the number without a variable, just the constant, is your C term, right? And in these instances, the A term tells us whether the parabola opens up or down. And it's fairly, like I like to say, if it's negative, frown, down, right? Because a parabola makes this shape or it makes this shape, right? So if A is negative, it looks like a frown, it opens down. So this is when A is negative, this is when A is positive. The C term is your y-intercept. So just the C term in standard form tells you where the parabola crosses the y-axis, okay? So in this case, our parabola would cross the y-axis at positive 5. So C equals the y-intercept. That's just some background information. And we need B to figure out the axis of symmetry. So our formula for axis of symmetry is the opposite sign of B. The opposite sign of B over 2 times A. So in this case, what's the opposite sign of positive 6? So let's write this out first. So A equals 1, B equals positive 6, and C equals 5. So if we're going to put these into the formula, negative B, so opposite sign of B would be negative 6 divided by 2 times A, which is 1. So negative 6 divided by 2 is negative 3. So we've just figured out that our axis of symmetry is the same as our last one. That's kind of funny. All right, so our axis of symmetry is at negative 3. So that's our AOS. So x equals negative 3. That means 1, 2, 3. That means our axis of symmetry is going to come right through here. In this case, our A is positive, though. In the last example, our A was negative because our function opened down. This time, it's going to open up. So we need to find out where our vertex is. And if we want to find our vertex, we have to put this x value of the axis of symmetry back into the original function and solve for y. So f of x is the same thing as y equals 1x squared plus 6x plus 5. And we need to do this for x is negative 3. So we would say f of negative 3 equals. That's the value that we're putting in for x. That's how we write it, f of negative 3 equals 1 times negative 3 squared plus 6 times negative 3 plus 5. So negative 3 times negative 3, not negative 3 times 2. Negative 3 times negative 3 is going to be positive 9 plus 6 times negative 3 is negative 18 plus 5. 9 minus 18 is negative 9 plus 5 is negative 4. So our y coordinate of our vertex is negative 4. So that means we go down 1, 2, 3, 4. So here's our vertex. We also know that it crosses the y-axis at positive 5. So we know that this is the lowest point. It opens up, so this is going to be a minimum. The coordinate is negative 3, negative 4. That's our vertex. It's getting sloppy. And now we can sketch our parabola. I know that 1, 2, 3, 4, 5. I know it crosses my y-axis here. That's 3 away from our axis of symmetry. So that means because parabolas are symmetrical, right? That means if I go 1, 2, 3, I can go 1, 2, 3 and get another point. So now I have my minimum and I have 2 points on the function. Let's see if I can get this. It's a little messy, but this is my parabola. So that's why you want to find the axis of symmetry, because by substituting it back into the original function for x, you solve for y, you get the y coordinate of your vertex. So now our vertex is at -3, -4. That's why we use it. So hopefully this helped.